All right, we've already done the first derivative test, so if you remember what that is and you've got that sort of handy in your notes, maybe you don't even need to write this down, but it flows into what we're going to do next. So I'm going to recap here. F has a relative minimum when F has a relative minimum, first derivative, so I probably need to say something about the first derivative. Do you remember how to complete that sentence?
No.
F has a relative minimum when F prime changes from
decreasing.
Let's see, if I want a minimum, it needs to change from negative to positive. Yeah, negative to positive. Maybe a little picture. Yes, a relative minimum. F prime changes from negative to positive. And once you got one of them, it's easy to know the other one. F has a relative max, so top of a mountain, when F prime changes positive to negative. But let's look at those pictures a little bit more and see if we can come up with another test. So that's the first derivative test, because it's based on the first derivative. So a picture of a min and a max. There's the min. There's the max. Something they have in common is that F prime equals 0. But now that we know about concavity, second derivative stuff, what would you say about the concavity at the minimum? Is that concave up or concave down?
Concave up looks like a cup.
Concave up like a cup. So that means the second derivative is positive. At a maximum, it's concave down like a frown. So that means the second derivative is negative. We're going to put those together, we can write a second derivative test. Basically based on those pictures. If F prime equals 0, and I guess we'll do the minimum first since that's the one we wrote first, F double prime is greater than 0, positive, then F has a relative minimum. Let's write the other one and then we'll pause for a moment. If F prime equals 0 and the second derivative is negative, meaning concave down, then F has a relative maximum. To To me, this is not one of those things that you put on a note card to memorize. This is something you read and sketch out and think, and then you can reach your conclusion. If f prime is 0, that means you're at a flat spot in the graph. Second derivative greater than 0, that means you're concave up. And if both of those things are happening, then you've got a relative min. Same thing for the second case. If f prime is 0 and you're concave down, then you've got a relative max. So some students think, okay, I need to go memorize all these different combinations and what they mean. I say, no, don't do that, because you might get them backwards and you're kind of wasting your time. Know what f prime means. That means slope equals 0. Know what the second derivative means. That means concavity. And I can't put greater than or equal to because it could be either one. So if you know what first derivative and second derivative are telling you, then you can make conclusions about maxes and mins. Okay, so the conclusion of the first derivative test and the second derivative test are the same. Like they both tell you you've got a max or a min. It's just different ways of getting there. And so some people are like, well, why wouldn't I just use the first derivative test all the time? And normally you probably would, because you take a first derivative, you set it equal to 0, you set up the number line, and all is well. We can rig the problem to force you into the second derivative test, basically. And you'll see that on the assignment today.
You're so kind.
Yes. An example problem. If f of 4 equals -3, f prime of 4 equals 0, and f, better not change to g, that who knows what that would mean, f double prime of 4 equals 2, I'm leaving some space to write some notes here. What's going on at x equals 4? So I'll give you some maybe random information, and we got to piece it together here. So f prime, what does that tell us about the graph of f? Slope.
It's differentiable into 2.
The second derivative, what's that tell us about the graph of f?
Concavity.
And so is this one concave up or concave down?
Concave up.
Second derivative is positive, so we're concave up. That first one, I guess if we want to call it anything, that's just a point. So 4 - 3 is a point. So we've got a point where the slope is 0 and it's concave up. You don't really need to sketch it, but maybe it's helpful. So there's my point 4 - 3. There's a tangent line slope. Maybe that's a better way to say it. So the tangent line slope is 0. It's concave up right there. So what's happening at x equals 4? What would we call that point? A relative minimum. Make sure you include the word relative, because we're going to talk about another type of minimum in a moment.
I'm assuming absolute.
The absolute minimum and maximum. Let's talk about absolute max and min. This one is easy in theory. It's more about how do I find them. the absolute max is the maximum y value of the entire function. Yeah. Max y value of the entire function. So I'm not concerned about the top of a hill, the bottom of a valley. I just want like the peak. Not all the peaks that are, relatively maximums, but just like what's the highest peak in the whole graph? That's the absolute max. And the absolute min, same thing, is the minimum y value of the entire function.
Why are there so many quotes?
Because I don't want to write out the whole words again. I'm just saying max is the overall max, absolute min is the overall min. Maybe that's the easier way to say it. That makes sense. Almost said there's one. There could be more than one absolute max.
I just wrote.
Because they could, if they're tied, right? If there were two highest mountains that were the same height, there would be two absolute maxes.
I just wrote and vice versa.
I don't know that vice versa applies
I meant
there,
like
but
vice versa for like min.
is an absolute extrema always a relative extrema? It's an absolute extrema always a relative extrema.
Another square is a rectangle.
It's a square rectangle situation. Why no? If you think no.
Wait, actually, yeah.
I agree with that.
But not the other way around.
Yeah.
Yes. Okay, so
Yeah.
you can definitely have relative extrema that aren't the top extreme, right? Like that's not the absolute max. Here's the trick. The answer to this question is still no. Because the endpoints are not relative extrema. No, because endpoints. So if it weren't for endpoints, it would be yes. But because the endpoints can throw us off, we have to be careful with endpoints. And I guess to make an example of a minimum. So that graph has lots of relative maximums and minimums, but its absolute max and min are not relative max and min because they are happening at the endpoints. So
But within the interval, is it true, like not disregarding endpoints? Like if you just picked a part of
yeah, but you can't. If you pick an interval, you've set some endpoints.
Well, yeah. But I'm saying like within the graph.
But within the graph implies endpoints. So here's the
You
thing.
know what I'm trying to say?
I don't. Let's find the absolute. See if I can spell. The absolute. Let's do minimum. The absolute minimum of f of x equals x to the fourth minus 32x plus 4 on negative 3 to 3. Oops. Absolute minimum of that weird function on negative 3 to 3.
Is that something you made up just now? Or?
No, I have that one because it's going to work out for us. So absolute minimum, again, if you see absolute, your brain should be thinking, I've got to check the endpoints. So we're just going to check, it's called a candidates test. It's the fancy name for it. You frequently use that name, but that's what it's called. And our candidates are the relative extrema and the endpoints. Because if we're looking for absolute, we've got to remember to check the endpoints. That is a major issue on homework, on our test, on the AP. If it says find the absolute, so many students, they know how to take a first derivative, set it equal to 0, figure out if it's a max or a min, but you got to check the endpoints. And really, it's just a table of values. So -3 and 3 are on there because those are my endpoints. But I also need to check, you know what, I don't know if they're relative extrema or not, so instead of calling it that, let's call them critical points. Let's check the critical points and the endpoints. So first derivative, 4x cubed minus 32. Yeah, 4x cubed minus 32. We'll set that equal to 0. Factor out a 4. Because I'm looking for critical points. There's only one. Which is nice, because that means there's less points to check. So my candidates are the critical points and the endpoints. If I want to know which one of those is the lowest of the lows, what do you think we could do? This is like Algebra 1 stuff that we're about to do. Just plug them in and pick which one's the lowest. So f of -3. Ooh, 3 to the 4th is 81.
Yes.
Plus 32 times 3.
96.
Plus 4. Well, that was a little bit of a hand for us there. 181. If I plug in 3, 81 minus 96 plus 4, -11. If I plug in 2, 2 to the 4th is 16 minus 64 plus 4, -48 plus 4 is -44. So now I just look and say, well, the absolute minimum would be right there. Let's be careful how we say this. The absolute minimum of -44 at x equals 2. So be careful how the question is worded. The absolute minimum is -44. That's the y value. Where it happens is x equals 2. A lot of times you can get around the problem by just giving the ordered pair. And you can kind of just sneak your way around it that way. All right, the only other thing you have to worry about with absolute min and max, let's see.
Is them trying to trip us up?
Almost done. All right, what's the absolute min of that problem? Assuming that my picture is nice there.
-1 at whatever.
So the minimum is at -1. I don't know where it happens, but the minimum is -1.
And then max is 5.
The max is not 5.
Oh, that's an endpoint.
It's an endpoint, but more important than an endpoint, what's making that kind of weird? It's an open circle. So the maximum value of this function
It's just screwy.
is not 5, because it doesn't get to 5,
4.9.
but it's more than 4.9, and it's more than 4.99.
Could you just pick something?
and it's more than
4.999.
4.99999.
4.999. Oh.
So even though it doesn't go up forever, we can say it doesn't have an absolute max because it doesn't ever. There's no number to say it gets to. All right, your job is the rest of worksheet 3. Answers are posted. I will be back on Friday to answer lots of questions.
Right after a pep rally.
After a pep rally, you have a quiz tomorrow.